So I tried to give you a way to quantify our cosmic insignificance, and we started by doing it in a universe that was geocentric. But as we'll see, by measuring parallax angles, essentially we were able to discover distances to almost the entire galaxy and to understand that our universe expanded way beyond the solar system. And if you want to have fun, you can actually update the universe instead of being just a solar system to it being the radius of the full galaxy. So this implies something like 9.5 times 10 to the 17 kilometers. And keeping the volume of a human, again, spherical human, to something like 10 to the minus 10 cubic kilometers. So this means that even in the good old times where our galaxy was the full universe and we didn't know about any other galaxies, our cosmic insignificance was still rather shocking. So we were talking about a ratio between our volume and the volume contained within our galaxy of something like 10 to the minus 65. And you'll find examples in the lecture notes where you can, as I mentioned before, actually calculate what is the cosmic insignificance right now. Before we finish section 2, and again, you'll find further details on the lecture notes, and you can always find the corresponding subsections on the top of all the slides. It is important to introduce this concept of the astronomy distance ladder. Some of the first steps were the things that we're covering up to now. So it is important to understand that the first step really is to determine the speed of light really well. That allows us to then use radar to get the distance from the Earth to Venus, and then use Kepler's law, third law, to actually determine the distance between the Earth and the Sun. And once we have that distance, we can move further in the distance ladder and use that as the baseline to interpret parallax angles. This allows us to start to explore interstellar distances, and we'll see that there's then other methods that allow us to see further, and specifically how we can measure distances to other galaxies with C-fate variables. And towards the end of the module, and then in cosmology, you'll see how important these white dwarf supernova, or supernova 1A, were to, for example, discover dark energy. They are some of the kind of longest rulers that we can use to measure distances. And then finally, the largest distances really are measured by using redshift and using the Hubble law. But we'll get to those steps. In section 2, the important thing really is to understand how we measured parallax angles, and we can interpret them because we have the baseline of the distance from the Earth to the Sun, which is based on Kepler's laws and on the radar measurement. But as hopefully you saw, we could actually define and measure what 1 AU is without even knowing the speed of light by looking at the moon, the sun, and the relative positions and sizes. So this is it for section 2. And what I would actually encourage you to do is to go to section 2.5 of the lecture notes, where just like all the other sections after this one, you will find essentially questions with full detailed solutions. You should do them to not only challenge yourself, but also to understand whether you got the important parts out of the section, and so that you can note down any questions and bring them up for discussion sessions. Therefore, before we end, make sure that you really look at all the questions in the lecture notes, try them yourself, and look at the solutions. And I think it is really important that you try to identify anything that is not clear, bring those up in the first lecture, if you can, or any discussion session, or get in touch via Teams. And once you do that, I think you will be ready for section 3 and to do some rocket science. So I'll see you in section 3.